The SolarSync sensor measures solar radiation and temperature, and it is also equipped with a rain and freeze sensor. Therefore, it is important the sensor is placed in a location where it can receive full sunlight and receive natural rainfall. Based on the readings collected, it will adjust the run times using the seasonal adjustment function of the controller. Because the SolarSync only changes or adjusts the station runtime, we need to start out initially with a runtime selected that's indicative of the hottest time of the year. In order for SolarSync to take over the seasonal adjustment duties, we need to program the controller so the seasonal adjust is set via SolarSync. To do this, turn the dial to Set Seasonal Adjustment. The default is that the adjustment is done manually per program, affecting all the stations within the program. If you press the plus button while PRG Global is flashing, you will have the opportunity to program a different percentage by month. However, since we want to delegate this function to the SolarSync, we need to press the plus button once more to choose by SolarSync. We need to do this to every program unless we want to program some stations in a program and leave them out of the control of SolarSync. The wired SolarSync comes with 40 feet or 12 meters of wire, but you can extend it up to 200 feet or 60 meters using 18 gauge 1 millimeter wire. The wireless version consists of a wireless sensor and a sensor receiver, and they can communicate over a maximum distance of 800 feet or 240 meters line of sight. The sensor or the sensor receiver is connected directly to a set of sensor terminals in the wiring cabinet, S1 or S2 or S3. The order of the wires does not matter. It is important, though, that you remove the jumper that connects the two screws. Also, if no sensor is connected to one of the terminals, the jumper must be in place. After connecting the sensor, we need to configure it so the controller knows what we have attached. Turn the dial to Advanced Features, use the down arrow button to select Sensor Configuration, and press the plus button to access it. You will see the 3 sensor inputs corresponding to each of the 3 sensor terminals. If you have the plastic wall mount version, you will see 2 sensor inputs. Since we connected our SolarSync sensor to the first set of sensor terminals, then we will need to configure sensor 1 as SolarSync, using the plus or minus button. We will leave the other sensor inputs alone since we have nothing connected there. Once the SolarSync is configured, we need to check the sensor to make sure that there is good communication between the sensor and the controller. We do this by turning the dial to Set Sensor Operation. Here, we get to choose whether we want each station to acknowledge the sensor status or not. A check mark next to the sensor input indicates that the station will respond to the sensor and shut down irrigation when needed. A blank line indicates that this particular station will ignore the status of this sensor. The default is that all stations will respond to the sensor. However, if you want, for instance, stations 3 and 4 to ignore the rain and freeze inputs, then we need to advance to station 3 using the right arrow button and press the minus button to cancel the SIN 1, which corresponds to SolarSync rain and freeze alarms. We advance to station 4 and do the same. Once the SolarSync sensor is configured, we need to check the sensor to ensure a good connection between the controller and the sensor. To do this, turn the dial to SolarSync Settings, press the down arrow button to select Check Sensor, and press the plus button. If the communication is successful, the display will read OK. If it detects a problem, the display will show Sensor Failed, and you will need to check your connections. The Clear ET history would only be used if you had a SolarSync connected for a while and you wanted to erase any previous evapotranspiration readings. You can do this by selecting Clear ET history, using the up or down arrow buttons, and when you press the plus button to access it, the display will prompt you to hold the plus button to confirm that you want to clear the history. So once we have checked the sensor and configured it in the controller, we're now ready to program the region and the water adjustment. To do that, we'll want to choose the region out of the owner's manual, consult the table that's listed here in the manual, and you'll select the region that best describes your area. There are three ways of the third method is according to a general description of the area you live in. To change the region, press the plus or minus button. The water adjustment is the other setting you need to program. It is a 1 through 10 scale that allows you to adjust up and down in case you're overwatering or underwatering. Upon installation of the SolarSync sensor, it is recommended that you leave the water adjustment set to 5 so that you can adjust up or down from there. In fact, once you set up your SolarSync sensor, you'll want to monitor it for a few days to make sure it's not overwatering or underwatering. So if you notice that the seasonal adjustment percentage is too low for the weather condition and that all your landscape areas need a little bit more water, you can increase the water adjustment scale. Likewise, if you feel like the percentage is too high and your landscape may not need as much water, then you need to decrease the water adjustment level. This change will be reflected immediately under seasonal adjustment. However, if you still believe that this adjustment was not enough, you may have chosen the wrong region to begin with. If you feel like your entire landscape still needs more water, you may need to decrease the region number. If you need less water, you may need to increase the region number. So by decreasing the region number, it'll actually increase the amount of water. By increasing the region number, it will decrease the overall amount of water. That may sound contradictory, but it is all based on the expected evapotranspiration for that region. Therefore, since a low region number, such as a coastal region, expects to see low evapotranspiration rates, when the SolarSync detects a certain ET rate, such as 0.15 inches, it may almost be at the top of its range. So it will think that it is very hot for its region and will increase the run times. A high region number, such as a desert region, expects to see high evapotranspiration rates. Therefore, when it reaches the same evapotranspiration rate of 0.15 inches, this rate may barely represent half of the expected rate for this region. So it will think that it is not hot enough and it will reduce the run times. The water adjustment and the region should only be changed if all the stations need more or less water. If it's only a few individual